Hi y'all, we're back and we're going to continue our graphing. So we've graphed the first three trig functions. We spent a lot of time on sine, a lot of time on cosine. The last video we talked about tangent. So now it makes sense to talk about cotangent. So again, for the last time, trying to go through the basics, understanding the connection between what we started with trigonometry with in the beginning chapter to now graphing. And again, the concept is if you're given an equation that you want to graph and you have no idea what the pattern or the shortcut is, you can always resort to a t-table. So on my t-table here, I picked the angles out, and again, I picked quadrantal angles and our special right triangles angles so that we can look them up without a calculator. All right, so we're going to graph cotangent from 0 to 180 degrees, and you'll see why in a minute. All right, so let's first look up our quadrantal angles. So we're going to look up 0, 90, and 180. So to look up cotangent on the unit circle, we have our ordered pairs, our coordinates. And to look up cotangent, the definition is the reciprocal of tangent. So tangent was y over x, cotangent's x over y. So if I go to 0 degrees, x over y would be 1 over 0, which is undefined. Good. If we go to 90 degrees and we do x over y, 0 over 1 is, that's right, 0. And if we go to 180 degrees, x over y is negative 1 divided by 0, which again, we can never divide by 0, is undefined. All right, so far so good. Now we're going to look up our special right angles. So we're going to go to 30 degrees. And remember, all these triangles are drawn in quadrant 1, because 30, 45, and 60 are in quadrant 1. So according to this picture, here is our x, here is our y, here is our r. X, y, r. X, y, r. Okay, so even though I don't have the 4 quadrants drawn, I have it drawn like the triangles would be in quadrant 1. So we're going to do 30 degrees. If we do x over y, square root of 3 over 1 is square root of 3. If we do 45 degrees, x over y, 1 over 1 is 1. If we do 60 degrees, x over y, 1 over square root of 3 would be rationalized to square root of 3 over 3. Now we're going to do 120, 135, and 150. So to look up the trig function cotangent, for these angles, we know they're all in which quadrant? That's right, they're in quadrant 2. So we would need their reference angle. So if we think back to chapter 1, what is the reference angle rule in quadrant 2? It's 180 minus the angle. So if I do 180 minus 120, I get 60. So I'm really looking up the cotangent of 60 degrees, which you told me here is square root of 3 over 3. 135 is in quadrant 2. So the reference angle is 180 minus 135, which is 45. So the cotangent of 45 degrees is 1. For 150, the reference angle would be 180 minus 150, which is 30. So the cotangent of 30 degrees is square root of 3. But according to all students take calculus, if these angles are in quadrant 2, what is your cotangent value? Well, let's think quadrant 2. All students. S stands for sine, and it's reciprocal cosecant. They're positive, which means these values are negative. Everybody good with that? Awesome. Now that we have our t-table filled in, we can see we have 1, 2, 3, 4, 5, 6, 7 ordered pairs. Remember, the undefined does not make an ordered pair. Undefined means you have no y value, and you can't plot a point without having a y value. So just like with tangent, cotangent has 2 undefined values, which means there's going to be 2 vertical asymptotes in your picture. And they are going to be at 0 degrees, or 0 radians, and 180 degrees, which is pi in radians. Okay? The other points do have x and y values, so we will actually be able to plot them. But remember, we're going to have to set up our x and y axis. So we're going to need all our x values, angles, and radians. So let's review how to make radians again. 30 degrees is what in radian measure? Well, think about it. Pi stands for 180 degrees. What would you divide 180 degrees by to get 30? That's right, 6. So this is pi over 6. What would you divide 180 degrees by to get 45? That's right, 4. So this is pi over 4. What would you divide 60 degrees by? What would you divide 180 degrees by to get 60? That's right, 3. So that's why 60 degrees is pi over 3. What would you divide 180 degrees by to get 90? That would be 2. That's why we're pi over 2. Now, to get the other radian measure, we don't need to do the old conversion back in chapter 1. We just need to think. 120 is 2 times 60, right? Well, you know 60 is pi over 3. So 2 times 60 would be 2 pi over 3. 135 is 3 groups of 45. So we would do 3 groups, 3 times pi over 4. 150 would be 5 groups of 30. So we want 5 groups of 30. That would be 5 times pi over 6. Just to make you start thinking about how you can do the conversions quickly in your head. Now we're going to go label. And we've discussed this several times. And again, look very carefully. Don't just start marking every blue line with these radians. Are these radians all in the same scale? The same increment? Well, no. From 0 to 30 degrees, you're going by 30. But then 30 to 45 is by 15. 45 to 60 is by 15. And then 60 to 90 is a jump of 30. Well, guys, you can't mark one line by going by 15s and the next line by going by 30s. So to scale this correctly, every blue line has to represent 15 degrees. So this is 0. That's 15 degrees. Well, I'm not going to mark it because I don't have a 15. 15 twice is 30. I'll mark that as pi over 6. Then another 15, that'd be 45. Then another 15, that'd be 60. Another 15 would be 75. It's not on my T-table, so I'm not going to mark that. Another 15, that would put me at 90. 90 plus 15 is 105. I don't have that. 105 plus 15 is 120. I'll mark that. 120 plus 15 is 135. 135 plus 15 is 150. 150 plus 15 is 165. I don't have 165 degree angle on my T-table, so I'm going to leave that line blank. 165 plus 15, that puts me at 180. So if you look, I'm at 0 radians, then I skip a blue line, then I have my 3 radians, skip a blue line, have my 90, skip a blue line, have my 3 radians, skip a blue line, have my 180. As far as my y-axis goes, let's look at my y values. We'll be working on this. We all know square root of 3 is roughly $1.70. We all talked about this. $1.70 divided by 3 is roughly 57 cents, which I approximated to be 60 cents. And then these y values are negative. So negative 6/10, negative 1 7/10. Remember, we're doing a sketch. It doesn't have to be precise. You can't plot a decimal precisely on graph paper, but you can plot it between the right, correct integers. So here's y is 1, here's y is 2. Y is negative 1, y is negative 2. Okay, excuse me. Now we're ready to plot. So let's just follow our T-table. At 0 degrees, we are undefined. Undefined means that's where I will draw my vertical asymptote. So my first vertical asymptote will be on the y-axis. That means my cotangent curve cannot cross that. My second point at 30 degrees is up to 1.7. At 45 degrees, I'm exactly at 1. At 60 degrees, I'm at 6/10. Then at 90 degrees, I'm at 0. At 120, I'm at negative 6/10. At 135, I'm exactly at negative 1. At 150, I'm at negative 1 7/10. And at 180, I'm undefined, so there's another vertical asymptote. So if we connect the dots, remember, connecting the actual dots to make the curve is not hard. Remember, it is a curve. Do not make a line. And it doesn't stop. Remember, the whole point of the asymptote means the curve is going to get close to the asymptote but never touch it. So here on the left, it's going up. Here on the right, it's going down. That is a cotangent curve. Now, a cotangent curve and a tangent curve have a lot in common. First of all, they have two asymptotes with a point in the middle. So when we go to graph this quickly, we're not going to need to plot all 7 of these points. We're just going to need the point in the middle. What I do want you to notice is different, the placement of the asymptotes. So think back to the previous video. Where are the asymptotes for tangent? On the parent graph for tangent, the asymptotes are at negative 90 and positive 90. For cotangent, the asymptotes are in a totally different location. For cotangent, for the parent graph, the asymptotes are at 0 and 180. So you need to memorize that. What is the location of the asymptotes for cotangent? They are normally, for the parent, between 0 and one's at 180, which means the point's at 90, smack in the middle. What I do want you to notice is this is also a discontinuous function. Remember, all trig functions are periodic, which means they follow a pattern. So if you had this on a graphing calculator, there'd be another cotangent graph here and another cotangent graph here. But what happens is when you go to trace, you would trace this cotangent, pick your finger up, and then start the tracing again. So that's what makes it discontinuous because of the asymptotes. The second thing I want you to notice is we have no amplitude for cotangent. Remember, what does the word amplitude mean? It means height. There is no height because the arrows indicate cotangent will go as high as it wants to positive infinity, as low as it wants to negative infinity. So when we talk about tangent and cotangent, you cannot say there's an amplitude or height. The third thing that's different is the period. It does not take 360 degrees to draw a cotangent. Just like tangent, how far apart are the asymptotes? The asymptotes start at 0 and go to 180. That's 180 degrees. So to draw one complete cotangent curve, which this is, you don't need 360 degrees, you need 180. So the period for tangent and cotangent are both 180 divided by the frequency. Okay? Those are all important concepts to know. So what you need to memorize is you need to know if I ask you to graph the parent function y equals cotangent x, the asymptotes will always be at 0 and 180, and the point would be smack in the middle at 90. Tangent goes up, cotangent goes down. So we say cotangent is decreasing. Now, how do you remember that? Hold on a minute, let me get a piece of paper and show you. Okay, watch this, guys. This is really cool. On this piece of paper from the previous video, if I draw a tangent curve comes from the bottom and waves itself up. What is the relationship since the beginning of this semester between tangent and cotangent? They're what to each other? They are reciprocals. Now, when you think about the word reciprocal with numbers, what do you think it means to do? Good, it means to flip. So we all know if I give you the number 2/3, that fraction, the reciprocal of that would be 3/2. Well, the same is true. If you take a tangent curve and you physically flip it, there's your cotangent. There it is, guys. Isn't that neat? So the same thing applies. Watch. There's tangent, left to right, going up. I'm going to flip the paper. There's cotangent, left to right, going down. So our graphs still preserve that connection between tangent and cotangent. So again, to sum it up, to graph a cotangent curve, we're not going to need to know all of these points. When I say graph cotangent, all we're going to need to know is the point in the middle, which is at 90 degrees, and the two vertical asymptotes, 0 and 180. Okay, in the next video, we're going to do some transformations to cotangent.